Okay, lesson 5.1. All right, today's lesson is going to be a review of exponents. All right, review because there's hopefully not going to be any new information taught. This is just a refresher from concepts that we would have been learned in grade 11. All right, so we'll start off the lesson by going over some laws and definitions, and then we're going to get into examples which will apply those laws and those definitions. So recall. What you're looking at here, this is what we would call a power, all right? And a power is made up of two parts. The B that you see, that's what you would call the base. And the N is what you would call the exponent. So you'll see exponent laws, all right? But, this might sometimes be referred to as power laws. And our first law has to do with multiplication of powers. So when you are given b to the m multiplying b to the n, what this says is if these are the same base, okay, so in this case they're both b, you can simplify this to just by writing the base and then adding up the exponents. So in this case it would be m plus n. Division is very similar to multiplication. They're just inverse operations, right? Multiplication and division are inverse. So you would expect a similar thing to occur with the exponents, all right? What is the inverse operation of addition? Well, subtraction. So in the division exponent rule, and you have same bases here, you're gonna subtract exponents. So you rewrite the base, b, and you take your top exponent, m, and you subtract your bottom exponent, n. Okay, power of a power, or power to a power. All right, we have three different scenarios here. So what happens when we have a base put to an exponent, and then that is also then put to an exponent? Well, an exponent to an exponent says multiply them. So in this case, this would be b to the m multiplying n. So this n, whatever exponent is out here, gets distributed to this exponent. And when I say distributed, I mean multiply. If you were given two different powers, this a and this b right here, you would distribute it just like we did above. You would distribute this power n to this one right here and to this one right here. You would multiply them both. So you would have this base a put to an exponent of p, and that would be multiplied by n. You would have the base b, right? These are multiplying here, so still multiplying. Base b to the power of q, and that would be multiplied by n. All right, so you multiply all things, apply to every power, okay? And you would do the same for this one too, even when it's a fractional, all right? There's a fraction on the inside, but the same thing applies. You take this n and you multiply that exponent. So that's a put to the power of p n, and then you have the fraction b put to the power of q, and that q is being multiplied by the n, the exponent that was on the outside of the bracket. All right, so those are what happens when you do power to a power. Well, let's look at some other different rules, okay, some other definitions. The zero exponent. So what this says is any base, anything, okay, any number, put to the exponent of 0, this will always be equal to 1, okay? So any base put to the exponent 0 is 1, always, okay? It's always 1. The negative exponent, all right? One of the biggest mistakes I see is that people think the negative exponent means multiply by negative. So this does not mean negative b to the n. That is not the same thing. What a negative exponent says is take this base, whatever is being put to the exponent, and flip it upside down or reciprocate it, okay? So when I say flip it, what I mean is you write it as 1 over whatever it was, so in this case, b. And you do that, and that's how you get rid of that negative exponent. So now you have 1 over b put to the exponent n. And then if using the rule that we just learned up above, this one right here, we can then distribute this n to here, that 1 right there, and 1 to the power of anything is still 1, or in that n can go down here. So we can rewrite this as 1 over b to the n. Well, what happens when there's a fraction on the inside? Well, you're still going to reciprocate your base. So if we can think of this first problem we did as b over 1, right? Because anything divided by 1 is still itself. Well, look, b over 1 became 1 over b, right? You flip your numbers. So the same thing would happen here. If it's as a over b put to a negative exponent, well, now it would be b over a. And then that would be put to the positive exponent now. And then if we wanted to simplify this further, right, you can use the rule, once again, this fraction one that we see here, that says, hey, take this n, distribute it to that b and that a. So that would then become b to the n over a to the n. Our third one, rational exponents. So rational, another way to think of it is like, again, well, unit 2 we did the rationals, but fraction, right? So what happens when you have a fractional exponent? So there's 2 examples. The first example, right, we don't really have a numerator. The numerator is 1. So if you see a numerator 1, the only thing we care about is the denominator, right? And in this one, what the denominator says to do, it says take this base right here, so that b, and you are going to take the root of whatever number it is here. So in this case, it's the nth root, okay? So you take the nth root of b. Well, when you are given an exponent, or sorry, a fraction of exponent, but in this case we have a m here. Well, let's first talk about the n. You see that we still have an n on the bottom? Well, that's going to be the exact same thing. So we're going to have n root b. But the only difference between the first example and the second one is this m that we see here, this m. So what that tells us to do is take all of this and put it to the power of m. So it really doesn't matter what order you do things in the sense that you could evaluate the root first and then put it to the exponent, or you could do the exponent b to the power of m and then take the nth root, okay? It does not matter what order you do them. Both are equivalent. Those mean the exact same thing. So let's apply these rules, these definitions and laws to examples. So let's look at example A. We have -8 in the bracket, and that's being put to the power of -1 over 3. So first step, get rid of that negative exponent, all right? So we want to address the -1/3 in the exponent. Well, to get rid of that negative exponent, that says reciprocate the inside of the bracket. So the reciprocal of -8 becomes -1 over 8. And that allows us to get rid of that negative exponent. So we have now 1/3 up top. Okay, well, let's simplify. Oh, it says simplify and evaluate, right? So we're just going to reduce it down, and then we're actually going to evaluate. So now we have a fractional exponent. So we have to look at the denominator, and it says, hey, take whatever's on the inside of that bracket and do the third root. So what this is saying is take the third root of -1/8. Well, and let me write it actually like this, 1/8. Okay. Well, we can take the root of both the numerator and the denominator. We can distribute that root to the top. So third root of -1. And we can distribute that third root to the denominator, 8. And now, just use your calculator, all right? So third root, if you don't know the button on your calculator, or even just doing it in your head, what third root means is what 3 numbers multiply to give me what I need, right? So in this case, what this part is saying right here is what 3 numbers multiply to give you 8. Well, that'd be 2, 2, and 2. So the third root of -1, well, what exact same 3 numbers give you -1? -1. What 3 numbers give you 8? 2. So there would be your answer for A. Let's look at B. Root 2 multiplying root 32. All right, so let's work with exponents. So in this case, we can undo these roots. So if we think about what a square root is, it's like having a 2 here, right? When you take the square root, is what 2 numbers multiply to give you on the inside. So if I'm asking you to take the second root, well, I can rewrite that first one as 2, the base, put to the 1/2. You could think of a square root as me saying, put something to the exponent of that fraction, or 1/, that root. Okay, so now you have 2 to the 1/2, 32 to the 1/2. Well, another way of thinking about this is using this rule right up here, where you had an exponent being distributed. So essentially we are looking at this right now, and I'm saying, go the other direction. Go this way. Go backwards. So if we have 2 to the 1/2, 32 to the 1/2, well, I'm going to undo the distribution of those exponents. So I'm going to undo it. That'd be like me saying 2 times 32 to the 1/2, right? Because I could distribute these exponents, and I would just get the line that I had above. All right, what's on the inside of the bracket? 2 times 32, that is 64. Put to the power of 1/2. Well, what is the square root, or what is the square root of 64? 8. Let's do C. -1/3 to the power of 0 plus -1/3 to the power of -2. So this first one right here, we have this negative being put to the power of 0. I don't care what number is in here. Any base put to the power of 0 is just 1. So this right here, anything put to the power of 0 just becomes 1. So this is 1 plus, well, now let's look at what we have on the side. -1/3 put to the power of -2. So first, address this -2 here. So that becomes -3/1 put to the 2. But anything divided by 1 is just itself, so -3. All right, so now we have 1 plus, well, negative 3 squared. That is just 9. So final answer, 10. D. Careful with this one, okay? So what this problem is not saying, this is not the same as me saying minus 4 over 2, okay? Those brackets mean everything. Because what this is technically saying is when I see negative, and then 4 to the power of 2, this is like me saying negative 1 multiplying 4 squared. And why this makes a big difference? Well, if we follow the rules of BEDMAS, which tells us how we have to solve something or simplify things, we have to deal with the exponent before we deal with the multiplication. So in dealing with the exponent first, that means we have to deal with the 4 squared, which would become 16, before we deal with the multiplication and get negative 16. Over here, the reason why this would be a different answer is the brackets would be the first thing you would deal with. And then, so inside the bracket, you would have that multiplication. So now that negative would be with the 4. And then you would do exponents. So that's why it would be like me saying negative 4, or you're expanding the bracket twice. And that's why you get positive 16, okay? So be on the lookout for this, all right? It's not the same thing as with the bracket. All right, a little more challenging problems. All right, now we're not doing with numbers. We are just simply looking to simplify here, all right? And key thing is leave answer in power form with positive exponents, all right? So we don't want any negative exponents in our final answer. So we have x squared multiplying y cubed to the power of 2, and that is all being divided by x squared y4. All right. So it doesn't matter what order you do things, okay? So the way that I am going to simplify this may not necessarily be the way you would have done it, all right? But there's many different paths to the same answer. So what I see first is I want to simplify this y up top. So I have a power put to a power. So I'm going to multiply those. So my numerator is going to become x squared multiplying y, and 3 times 2 would become 6. And then on the bottom, I would still have x squared y4. Well, we have similar bases, x and x, and y and y. So we're going to be using our division rule, exponent law division, where you take your base. So in this case, we have our common bases, x, and we subtract our exponents. So 2, take away 2. And then you have your other common base, y, and subtract the numerator exponent from the bottom, so 4. That would leave us with x0 times y2, and x0, well, anything put to the power of 0 is just 1, so your final answer would be y squared. B, a minus 2 times a to the 3 divided by a to the 5. Well, again, it doesn't matter which order you do things in. I'm just going to clean up the numerator first. So I see up top, I have similar bases again, a and a. So what that means is these are being multiplied. I'm going to use my multiplication law. So I add exponents, minus 2, adding 3, all over my denominator still, 5. So up top, I'm now going to be left with a to the 1. And on the bottom, I'm going to be left with a to the 5. Well, I have an a up top and I have an a on the bottom. So I'm going to now subtract my exponents using my division law. So 1 subtract 5, and that would leave me with a to the minus 4. And the problem said leave all answers in positive exponents. So that means we need to deal with that negative, and that tells us take your base and flip it. So this would become 1 over a to the 4. C. We have m squared put to the power of 3 over 8, multiplying m to the negative 3, all divided by m to the negative 4. So what I am going to do is I am going to simplify this bracket first. So I have m squared being put to the power of 3/8. So that means multiply exponents. So if I do that, that first one becomes m to the 6 over 8. Multiplying m to the minus 3 all over m to the negative quarter. Okay? Well, you're eventually going to get faster at doing these. You can see that we have same bases again, all m's. So we have a multiplication up top. So that means I will go m to the, and let me reduce that fraction, 6 over 8. So that's same as 3/4. Actually, you know what? I'll leave it here just so I don't do too many things in one step. So up top, I have multiplication. So I will add in my exponents. 6 over 8. And then I'm going to have to be adding the minus 3. But eventually, you're going to have to subtract, because you have an m on the bottom, this exponent, right? So you can get faster and you can start doing it all in one line. So I'm going to subtract negative 1/4 as well. So what I'm left with, and now I'll reduce that 6 over 8. I'll have 3/4 minus 3 plus 1/4. So if I deal with those quarters, right, I am going to be left with a full, so I'll have 1 minus 3. And then that leaves me with m to the negative 2, which I leave as a positive exponent. So I have to flip my base 1 over m, and then positive exponent of 2. D. 4n to the minus 1, 8, 3n plus 1, and 16n. All right, this is a little trickier. So if you want, pause the video and try it for yourself. See if you can do it, all right? The problem with this question, as opposed to any other one that we've seen, is none of these bases are the same. 4, 8, and 16 are not the same. So none of our rules will apply, because in order for any of the laws to work, we need to have same bases. However, you can manipulate them to have the same base. 4 is the same thing as 2 being put to the power of 2. 8 is the same thing as me saying 2 to the power of 3. And 16 is the same thing as me saying 2 to the 4. So let me use those and replace what I see in front. So this 4 right here is going to become 2 squared. And it's still being put to the power of n minus 1. So n minus 1. Multiplying that by, well, let's replace that 8. That 8 is the same thing as me saying 2 cubed. And that is still being put to the power of 3n plus 1. And then on the bottom, that 16 can be rewritten as 2 to the 4 to the n. Okay, so now we're almost there. But let's get rid of these brackets, okay? So we have exponents being put to exponents. So I need to multiply, and careful, when you have a binomial exponent, you have to multiply everything. So that n minus 1 is going to multiply that 2. All right, so that 2, that first one is going to be 2 to the n minus 2. Okay, you have to multiply everything. And then over here, you're going to have that 3 go into there and that 1, okay? So it'll be 2 to the 9n plus 3. And then on the bottom, much easier, you just multiply that 4 and that n, so that's 2 to the 4n. Now we have everything in the same base. See how everything is base 2? And we have a bunch of different exponents up top. So let's rewrite, as we did in the previous problem, all in one line. So we're going to write our base of 2, and then we're going to have our first exponent, this one right here, the 2n minus 2, and that's going to be being added, because there's a multiplication here. You're going to add 9n plus 3, and because this is all over this fraction here, that means it's division, so you'll have to subtract that 4n. So collect like terms now. So we have 2n plus 9n, so that gives us 11n, minus 4n, that will give us 7n. And then our constants, we have a negative 2 and a 3, that will give us plus 1. And that is your final answer, okay? So be on the lookout for rewriting each as a base of 2. All right, so star this question. You'll see this a lot. Last one. What can we do here? What does it mean when you have an exponent of 3? So careful with this, okay? What this means is you do not take this 3 and multiply everything in here. Okay, do not take that 3 and distribute it, because we have this negative in here, all right? Notice in the previous problems, when you did that distribution, let's go back up to the top when we first learned that, and I highlighted that you were being multiplying in here, okay? So technically this is still just one term, right? It's not a binomial. By introducing this negative here, it changes the problem, all right? So pause the video and try for yourself. Think about what you can do here. Challenge yourself. And if you want to just follow along now, what I'm going to do, all right, how I'm going to simplify this. Well, I see that I have a x and a y in both of my terms there, okay? So my first step is I'm going to take out a common factor from my numerator. And inside, okay, so inside of that bracket, so it's still being put to the power of this 3 here, I'm going to factor out a x and I'm going to factor out a y from those 2 terms you see there. So in this first one, if I factor out a x and a y, I'll be left with just an x. And if I factor out an x and a y from the second term, I'll be left with just a y. So my bracket is a little too big, so I'll just reduce it. And then on the bottom, I still have x 4 and y 4. Okay, so now we have everything being multiplied. This is x multiplying y, multiplying this bracket here. You can think of this bracket as like z, right? It's being like x multiplying y multiplying z. So now it's similar to the way you've learned the law. So if that's the case, we can take this 3 and distribute it to that x, this y right here, and this bracket. So that numerator will now become x cubed, y cubed, again, multiplying between them. And that bracket is x minus y cubed. So that's what your numerator became. And on the bottom, you still have x4, y4. Well, we have 3 x's up top and 4 on the bottom. So again, we're just getting faster with our exponents. So if we end up subtracting this common base here and here, what we would find is that these 3 go away and you're left with just 1 on the bottom. These 3 y's up top reduce and you're left with just 1 y on the bottom. So we have x minus y cubed all over x, y. And that's your simplified answer. Okay, you can expand this out, but no, that's not the point of this question. All right, so that's the lesson for today. I'll see you in class.